of the day, Madan. He needs no introduction with an ideas to IT, but for the benefit of everyone, I'd like to give a quick introduction. Madan has been with us in Ideas to IT for 14 plus years, and he is our solution architect. And he has a vast and rich experience in architecting the solution right from the scratch. And beat any
Sorry to interrupt,
technology under
ma'am.
the sun,
Sorry to
you can
interrupt.
rely on him.
Voice is very
So,
low.
without any delay, we'll start the session. Thanks, Madan.
Sorry to interrupt, ma'am. Your voice is unclear. Those who are all joined in virtual meeting seems to be low.
Yeah. Okay. So before we start into the session, so I want to know how many of you know the basics of blockchain, how it works. So how many of you are aware of the basics behind blockchain? What is blockchain and how it works? So hope everyone needs basic level of introduction for the blockchain, right? Yeah. Okay. So that is how this session is planned. So
Madan, sorry to interrupt, Madan.
So this is how the content is organized. So we have organized into 9 blocks actually. First one is Web3. So this session will basically cover the concepts of both Web3 and blockchain. So first we will introduce what is Web3. Okay, so hope everyone is will be a little bit ambiguous on what is Web3 actually. So I will introduce what is Web3 and why Web3 first of all. Then how Web3 evolved and what are the components in Web3. Okay, and then we will go to introduction into blockchain. So from here I will derive blockchain. From Web3 I will derive blockchain because most of us, even me at the early stage, right, was confused like between Web3 and blockchain and thought both are same. So I will tell you the difference between Web3 and the blockchain, and then the evolution of various blockchains, how blockchain behaves, and then what are the components involved in blockchain. I will get into the detail, and then we will move on to blockchain in detail. Here I will tell about the types of blockchain. So what is a smart contract actually, and then what is a token, NFTs, so which is a hot topic now, and then what are the oracles, and then how actually blockchain works, what are the basic algorithms behind blockchain, that includes cryptography, digital signature, etc. Okay, and then I will move on to 2 of the major leading blockchain platforms, one in the public space and one in the private space. Okay, public space I will cover the overview of Ethereum, and then in the private space I will cover about Hyperledger. Okay, at a high level, and then we will cover scalability solutions. Okay, so this is the technology solution, the 3rd generation blockchain, how to make blockchain scalable. This I will cover at a very high level because it involves a lot of deep understanding and some expertise in blockchain to understand the logic. So I will cover in a very high level what is a blockchain dilemma, and then what are the rollers and side chains, those scalability solutions I will cover, and then we will move on to the storage solutions. So moving from blockchain to the other part of the Web3, we have storage solutions, decentralized storage solutions, which we will have IPFS and Filecoin, and then we will conclude with how Web3 is now and what's the future of Web3. Okay, this is our overall plan. Okay, so Web3 is neither a standard nor a protocol. Okay, so it doesn't have any predefined rules. It's just a vision that people proposed. Okay, so Web3 emphasizes on primarily decentralization, censorship resistance, transparency, and interoperability. Okay, hope everyone is aware of decentralization. Decentralization is just moving away ownership from a single party rather than spreading the ownership across all the participants. Okay, that is decentralization. And then censorship resistance. Censorship resistance in the sense the content is not belonging to anyone. So it's not like anyone, even the website owner, can remove your content, moderate your content. Okay, so those kind of censorship we are resisting in Web3. Okay, and then transparency. Transparency in the sense, so everything is visible, the operation, how the application behaves, everything is transparent to all the viewers. Okay, that is transparency. And then interoperability, the ability to move across systems. Like people can now both move data from Ethereum to Hyperledger, Ethereum to any other blockchain, be Polygon or any other blockchain, or interoperability from one ecosystem to another ecosystem. So these are the properties that are emphasized on Web3. Okay, so Web3 doesn't have any rules. Okay, so covering all these topics, then your application is a Web3 application. Okay, that is the concept of Web3. Before that, why we should go for decentralization? Okay, decentralization. The first point is distribution of load. Okay, we no longer need to have a single entity that is responsible for handling all the load. Okay, of course we have load balancers, but in the sense the server is not a centralized one, the load can be distributed. The responsibility, okay, every other aspects can be distributed across all the participants. Okay, and then trustless. We no need to trust a single party. The trust is no more required because it is implicit now. Okay, because everyone is participating and we have strong security mechanism and like consensus algorithm, which we will go in detail further. So it's a total trustless environment. Okay, and then resource optimization. As I said, we no longer need to have a single resource to handle all the requests. So blockchain, in the sense decentralization, has led to decentralization cloud. Okay, whether it's replacing the complete AWS or Azure platform, there everyone is responsible of handling data, providing machines. Okay, so decentralization cloud, we have done some interesting projects in that also. That's an interesting area where the cloud is completely decentralized. So even I can let my laptop as a EC2 instance. Just an example I'm saying. Okay, that is one. And then fault tolerant. So single point of failure is not there. If a machine goes away, if it is a centralized system and the system is not reachable, the network is not reachable, of course, since it's decentralized, you can get the resource whatever you need from any other parts. Okay, because here everyone is server, everyone is interconnected, right? And transparency and availability, as I said before, so we know whatever we do, right? It's transparent to everyone in the ecosystem. It's not that it is hidden inside a central server kind of mechanism. It is transparent to everyone and it is more efficient. Okay, be it the speed or the reliability or the throughput. So it's more efficient when compared to a centralized system in a way. So in some way, Web2 will be better, and in some ways Web3 will be better. I will tell you where to apply what. Okay. Okay. Okay, this is how Web3 evolved. Okay, so in the 1990s, it was called Web1. Okay, so this is how Web1 was looking like. There will be a central server which will serve all the static pages, and every other client will just read the information, right? So static web pages like in previous days, Google or Amazon or Yahoo, okay, the news sites, whichever, right? So those were working on the model of Web1, which is completely read only. Okay, so we cannot contribute back the content to the application. So this is completely company focused. Whichever company, for example, Google means everything is focused on that particular company. It's not a platform, but it's just a website, not even a web application. Okay, that is called web model. And then in the 2000s, with the evolution of Orkut and Facebook, those kind of platforms, these websites became platforms. Okay, which is community focused rather than company focused. It was community focused. Okay, where individuals users can read the information and also contribute back the information. This is where the importance of data began. Okay, because users are contributing data to the ecosystem, and then companies started monetizing and they started working on that data. Where this is I would say this is the starting point where data science and other things evolve, and interaction is possible, right? So users can interact and personalize content. So based on the data you provide, the content produced will not be same for all the users. Okay, you can imagine Facebook or any other social platform, right? So the content will be produced to the users based on the content received from them, right? Like based on the users, since users started interacting, ads came in, and then the company started to gain some revenue out of the data produced by the users. Okay, so all these aspects began in Web2, which is read and contribute. Okay, And later in the 2010s, okay, this Web3 started to evolve, okay, where they say read, contribute, and own. So the major aspect is you read the content, you produce the content, and also you own that content. Okay, the content is owned, not owned by the community or the company, it's owned by every individual. Okay, and the main concept is since I am producing the content, I have the right to keep it or destroy it. Okay, the company cannot censor my content. The whatever the centralized authority cannot censor my content. And also, since I am contributing the data, see in Web2, users started contributing the data, and out of that data, company started to get some revenue. Now Web3 says the data owner is you. You also have the right to have some shares in the revenue in form of some incentives. Okay, that is where tokens came in, right? Tokens and other cryptocurrencies came in. So you have the right to get some incentives for the data you produce. Okay, so the ownership is completely decentralized. This is how Web3 started and this is how it's now. Okay, hope you understand the difference between Web 1, 2, and 3, right? Okay, why Web3? So in Web3, without our knowledge, the control will be digitally automated. So automated in the sense when you go for smart contracts and other things, you will come to know about this. So like there is no human intervention. We can drive it with minimal human intervention. Okay, and then trust, right? So we bring in trust since everyone the ownership is spread across all the entities. We need it's not like that if a centralized authority can destroy your content or a centralized authority can change your content without your consent. So we that is not possible in Web3, right? So it brings in trust to the internet and then promotes verifiable infrastructure. Verifiable infrastructure in the sense there's a chance to verify the authenticity of information in Web3, right? It's not like if a news content, if a news site publishes some news and it's not, we always trust that news site. The news is given by that site and we trust that it is true. And but there's no way we can verify whether that the content is manipulated or really authentic. But in Web3, it's possible to do that. Okay, that is why we go for Web3 based applications. Okay, this is how the current Web3 world is now. There are various areas where Web3 is focused. First is storage. For storage, right? We focus on decentralized storage system based on Web3, where we have IPFS and pipelines. And then even in browsers, instead of Chrome or Firefox, we have Brave, which is Web3 based browsers, and we have NFTs, non-fungible tokens. And then we have storage both. And then we have am I audible? Hello? 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 Okay. And then we have here is what blockchains come into place, right? Blockchain is one of the technology that favors the standards of Web3. Okay. So in storage and compute. So I will tell you what is blockchain, but it is a part of Web3 platform which facilitates us with the decentralized storage and compute layer and immutable compute and storage. Okay. And then we have based on these technologies, based on blockchain, we have cryptocurrencies where we have and see everything is interrelated. Nothing is on the domain. Gets the facility that one provides and then it reuses, right? So everything is interconnected. We have cryptocurrencies which works on top of a blockchain. We have Bitcoin and Ethereum, and then we have DeFi space, and then we have DF, distributed applications. Distributed applications in the sense which works on blockchain and other decentralized area where the application's data and the main computation logic is completely decentralized. Imagine famous we can view the source code of Facebook, right? So everyone can view the source code of Facebook and controls the execution of the complete application. Imagine how it will be. So that is what decentralized applications are. And then DAOs. DAOs means decentralized autonomous organizations, which is a little bit ambitious. So people are trying to work on it. Few have failed. It's at a very early stage. It's like companies that are completely decentralized. The execution is completely decentralized. For example, imagine we have an automated system where employees appraisal is decided based on few factors. If he meets some conditions in the smart contract, then it produces his what is his next pay hike will be, and then it gets automatically updated. Okay, and for example, if you want to decide whether you want to hire a new building for your office based on the employees, so that instead of a human intervention, this machine itself calculates and tell you it decides for you, right? Without any human intervention. So those kind of ambitious projects they are doing in DAOs at a very early stage. So it's not proven yet. So this is what the complete Web3 world is now. And a typical Web3 architecture, when you are developing a Web3 based application, this is how you do. So this you are already aware of in Web2. The presentation layer, the application and the storage layer is going to remain the same. Apart from that, this application layer will be in charge of connecting this presentation layer to the blockchain interface layer. See, this blockchain interface layer is an area where we have clients. If you are working in Ethereum, you would have noticed on Go Ethereum client and other blockchain clients, which connects to the actual blockchain network, right? So that particular responsibility this layer holds. Here we will have some SDKs and other things, the authentication needed for connecting to the blockchain and other decentralized network. So we will typically have blockchain with smart contracts deployed on them, and then we will have for storage. Typically, people use IPFS, right? For decentralized storage, people use IPFS because that is the most popular decentralized storage till now. Okay, this is how the entire a high-level architecture for a Web3 application will look like. And now we will jump into what is a blockchain. So hope everyone is aware of what is the Web3. And out of the Web3, we are going to learn what is blockchain and why it is related. So blockchain, it is nothing but a implementation of a distributed immutable ledger. Okay. So distributed ledger is a common term that is related to blockchain, but both are not interconnected. Like blockchain and distributed ledger is a kind of database which have its copy in almost all the systems. Okay, the database is not belonging to a centralized system, and it's an immutable distributed ledger in the sense we cannot change the data or manipulate the data once it is stored in the system. Okay, and data is represented as a set of transactions. So in blockchain, everything is a transaction. That is the most lower level representation, where transaction is nothing but from and a to. And data is transferring from one address to another address, or some execution is happening from one address to another address. and this is the input and this is the output. This is what a transaction looks like, and those transactions will be bundled into blocks, and it's a sequence of linked blocks. Each block is linked to one another, and next block is linked to a previous block. So that is why the name blockchain. Okay, I will dig in more detail. So this is how a typical blockchain will work. Be like transactions. There are multiple transactions. So in blockchain, so the transactions will be grouped into blocks, and there will be multiple blocks. For example, in a block, there can be some n number of transactions based on the size of the block. Okay. So the first block is always called the genesis block. So whenever the chain started first, okay, whoever has inserted the first few number of transactions, that will be in the first block. Okay, that block is called genesis block, and then we will have series of blocks, and I will tell you how it is named. So a block, this is what the content of block will be. We have n number of transactions. Okay, a transaction is a single data that is represented, and each of all these transactions will be grouped together, and the hash will be computed. That hash is called Merkle Merkle root hash. Okay, I will explain in detail what is a Merkle tree if you are not aware of. So a single hash will be computed for all these transactions, and it will be stored here. And apart from that, we will have a block version which depends on the network, and then we will have a n bits and then a nonce. N bits is nothing but a network difficulty. I will tell you in detail. So, for example, n bit is a number. So for example, 0.0001, something like that. Okay, a number. So, what people will do is, for all these transactions to be included in this block, they will do some logic based on this hash. They will do some mathematical operation. On top of this hash, they will apply a nonce. Nonce is a number ones. They will insert few random numbers, and then that operation should produce a number that is lesser than this n bits. Okay. So till we produce, we will do some trial and error, be it 100 times or 1000 times. We will change this nonce number, and then we will do a mathematical operation based on this factor, and then we will try to produce a number that will produce a result that is lesser than this n bits. Okay. Once that is done, this block is valid and then appended to the chain. Okay. So this is how proof of work works. Okay. It's just an illustration, but there are a lot more consensus algorithm which I will explain later. So this is what a block contains, and then of course it will have the hash of this block. This block will have whatever hash this produced, will have a hash of this block. Okay. Similarly, this block will have same content, but this previous block hash will point to here. So that is how the chain is formed. Okay. This is how a typical blockchain will be. So based on this, I will explain these characteristics. It is peer-to-peer. Peer-to-peer in the sense, so there is no centralized authority as I told, like in Web3. So data can be for a peer can retrieve the data from another peer which is not centralized. Okay. So everyone has a copy of it and can distribute it whenever it's needed. So undistributed, as I said, peer-to-peer undistributed. So everyone holds a copy of it. Okay, the blockchain, this entire data will be present in all the nodes. There is no central node that serves all the nodes. So everyone has a copy. Okay, every full node will have a copy. And then why it is immutable? So this is the most important characteristics of a blockchain. Okay, why it is immutable? For example, I have produced this data. This blockchain is formed. Now, a hacker or someone intentionally wants to modify the content of this transaction. Okay, he cannot do, because if he modifies this content, we can easily verify that the hash will not be equal to the hash that is already stored. Right? So the method hash is going to change. If you modify this content, then that hash, I can verify that. I will try to produce a hash and try to match if it matches this hash. Okay? So it will not be matched. So this block will be completely invalid. Not only this block will be invalid,
யாரோ புடவை
since
வாங்கி
the
கொடுக்கல,
hash is
புடவை
now
வாங்கி
changed,
வாய் மட்டும்
this will also become invalid because that is pointing to this.
நான் எத்தனை வாங்கி கொடுத்தேன்?
This is invalid. All the following blocks will get invalid because there's a chain that is formed based on this hash number. Okay.
அப்பதான் ஸ்பெஷல்.
Going to change, this is going to affect this, and then this block is going to be affected, and then subsequently all the blocks will get affected. Okay. That is why blockchain is immutable. Once you enter the data, you can change the data only by the visibility of others. Meaning, I will create another transaction saying that I am modifying this transaction. Okay. In that way, you can change, but we cannot tamper the data without the knowledge of others. We cannot change the data and make others believe that this
நேத்தே
data is
லட்டு பூந்தி ஒண்ணுன்னா சாப்பிட்டு
and pseudonymous. Pseudonymous in the sense the participant's identity is not really known. In the sense,
அப்புறம்
they will have
நேத்து
just
எப்படி
an
சாப்பாடு
address.
விட்டுறது? நீ
See,
விட்ட
Web3 will have a username,
ஒரு பூந்தி
email
ஒரு
address,
தோசை வாய் ஒரு
kind of thing,
பூந்தி
right? Where we can easily identify a people. But in blockchain, every participant is
Thanks,
identified
Sato.
only
Don't
through
stop,
an address. That address will be associated to a person, but a person cannot be identified by address. Right? So address is nothing but a public key, modified public key in a public key and private. Asymmetric cryptography, you have heard of public key and private key. So that public key is what the address of a person is. Okay. So I'm not saying it's anonymous. Anonymous means I don't know who made this, but it is pseudonymous in the sense I know this person, but I don't know the real identity. I can identify him using an address. That is why it is called pseudonymous. Blockchain is pseudonymous. Okay. So now you, based on this illustration, you know all these properties, how it is working, right? Okay. Okay. These are the blockchain components which I will explain in detail. First one is transaction. As I told, inside a block there will be a header, and then the body will have n number of transactions. That transactions will be sealed into a block. Okay, that is called block. Okay, and that block will be linked through pointers to previous block hash. That is called a chain. Okay, and then we have nodes. So this entire blockchain will be inside a node. Also, that will be replicated with all the nodes. Every node will be interconnected. This entire blockchain will have a copy inside all the nodes, participating nodes. Okay, that is have nodes, and nodes we have two types: validator nodes and member nodes. Member node means I'll just keep a copy of the blockchain in my system. That is a member node. Okay, validator node means I have the facility to add new blocks to a chain. Okay, not all the nodes can do that, especially in private blockchain, permission blockchain. Not all the nodes can do that. Okay, only few people can add data to this blockchain, and that will get broadcasted to all the nodes, and then they update the copy. Okay, so whoever have the copy and updates periodically, they are called simple members, and who have the authority to add new data, they are called validator nodes. Okay, and then we have miners. Miners are the people who are responsible. So all the transaction so whenever a transaction is created, they will be residing in a transaction pool. Okay, so new transactions, millions of transactions which are created instantly in Ethereum. So in a second, there are millions of transactions created, right? That will reside in a transaction pool, and there will be a group of miners, lot of miners, whose duty is to pick some transactions from this transaction pool. They will pick few transactions, and then based on the consensus algorithm, right? Based on a consensus algorithm is nothing but we have proof of work, proof of stake. So based on that logic, they will do some work, and then they will group this transaction and seal it into a block, and then they will add that new block into the chain, which will be broadcasted, and every member node will update their copy. Okay, so the miner duty is to group few transactions in the transaction pool into a seal into a block, and then add it to a chain. So that is done based on consensus algorithm. Okay, we have a predefined set of rules. So how to validate a transaction, how to add them to the block, we have a rule that is called consensus. Okay, and last we have wallets and addresses. As I told, address is nothing but a identity of a participant, and that identity is stored inside a wallet. I will explain in detail. Okay, so these are the components of a blockchain, right? Hope everyone is clear. Okay, these are the evolution of blockchain. Okay, how blockchain evolved. We have first generation blockchain 1.0, which is Bitcoin. Bitcoin is the first one who brought blockchain into limelight, because they started cryptocurrencies. Okay, for crypto, they wanted a decentralized transfer of currencies from one party to another without the intervention of a centralized party called banks. Okay, that was their ambition. For that, blockchain was a only supporting technology available. So this is where people started confusing between cryptocurrencies and blockchain. Cryptocurrency and blockchain are not same. It's just a difference between email and internet. Okay, the first use case of internet was email, the first proper use case. Likewise, the first proper use case of blockchain which people saw in reality was Bitcoin, cryptocurrency. So Bitcoin introduced the cryptocurrency. Okay, and they use blockchain only for cryptocurrency, currency transfers. Then we have 2.0. After that, Ethereum. With the introduction of Ethereum, what Ethereum thought is, why people are using blockchain only for cryptocurrency transfers? Why can't we utilize them for other computation? Okay, decentralized and immutable computation. So, with the introduction of smart contracts, Ethereum, in addition to cryptocurrencies, they leveraged the smart contracts. They facilitated decentralized apps, as I explained before. So all these things came into picture after the introduction of Ethereum. Okay, that was the first blockchain development platform that introduced these things. So they are called second generation blockchains. Okay, and then came third generation blockchains, where they were trying to solve few problems that blockchain had. Okay, I will explain in detail. One is obviously scalability. Okay, because initially Ethereum's throughput was just 15 transactions per second. Okay, imagine, so there are millions of users, but at a second only 15 transactions can be committed into a block. Then the waiting time will be minutes. Sometimes the network is too busy in hours also. Okay, that was one major problem with blockchain. So people were trying to solve that scalability, interoperability issues with the blockchain, and that was third generation blockchain. Even Ethereum gave few proposals, and then Polygon, Binance, and other blockchains came to picture. And 4.0, it's still an ambitious one, industry and infrastructure based, specifically tailored for few industries like healthcare. So industry based blockchains they have started developing, but we are still in this third generation, at the early stage of third generation, not early stage, but a little bit mature stage of third generation blockchains. We are still there. Okay. So we will jump into what is the various concepts of blockchain in detail. The first one is the types of blockchain. Okay, we can segregate them into permissionless and permission. Okay, as I said, blockchain is distributed across various nodes, so everyone can participate. Everyone can group transactions and post it into the block. That comes under permissionless. Okay, they don't need any explicit permission. Just they can join the network, do whatever they want. Okay, because consensus algorithm is there to safeguard the protocols, various protocols, and they will follow those protocols, and then they will add data. So that is permissionless, where Ethereum, Bitcoin, other things come into picture. Okay. Next one is permission. Okay. Permission in the sense, we need permission. People need permission to participate in the ecosystem. Be it minor member nodes or validator nodes, they need permission to connect to the network. Okay. Some identity they have to provide. That is permission. In that we have private and consortium. Okay. Okay. Public blockchains, as I said, anyone can participate without explicit authentication, except that we can restrict them at the network level. But as in the picture, we cannot restrict them. Anyone can participate. Examples are Ethereum, Bitcoin, Polygon, and all those blockchains come into this public blockchains. The advantage is being complete decentralization. So still they respect the concept of decentralization. We are not restricting anyone, right? It's completely decentralized. They are saying, and then security is high. There it will be highly secure, because since it is completely decentralized, all precautionary measures will be taken to make the system secure. For example, in proof of work, not anyone can add the data, right? They have to do some work to prove that they have validated the data, and then they are adding it to the block. Okay, and transparency. So since it's public, everyone can see what is happening, what all the data that is being transferred and added to the block. Anyone can see. It's completely transparency. But the disadvantage, low throughput. As I said, since it's a public blockchain, there are millions of transactions and a lot of participants in the ecosystem. So the throughput will obviously be a little bit lesser. And transaction cost, this we will see in detail. Transaction cost means we have to pay some amount, some coins, or in the native cryptocurrency, we have to pay for our transaction to be added to the block. Okay, so there will be some transaction cost involved, and then enterprise adaptability. Still some enterprises feel unsecured because, like, since it's a public blockchain, anyone can participate. How can I move my data into a public blockchain? So the adaptability rate is still low in enterprise. Next is private blockchains. So Hyperledger. Hyperledger is one example of private blockchain where we have to prove our identity and we have to explicitly approved by authority to participate in the blockchain environment. So the centralization is little bit broken. Okay, because decentralization is little bit broken and we are leaning slightly towards centralization because there is a single authority that validates the authenticity of the participants at least. Okay, so the centralization is little bit coming in, and then it's prone to compromisation because it's happening between a closed environment, right? Then how can we have the trustless factor of decentralization, right? So that is not happening here. There is advantage, high throughput, because it's completely centralized. We have the authority. There is a pure number of transactions happening between a closed environment. Throughput will be higher, cost will be lower, and enterprise adaptability. As I said, since they feel it's secured, a private blockchain will be secured for them. A lot of enterprises for various reasons they will go for this. Next is consortium is another kind of permission blockchain which has all the property of a private blockchain, but it will not be owned by a single person. Okay, that fact, whoever is authenticating the participants, that will not be owned by a single person. It will be owned by a group of people across organization. A group of organization will own that environment. Okay, and at last we have hybrid. I am not going much into detail. Hybrid is nothing but a few portion of the blockchain will be public and few will be maintained private. So those kind of things hybrid blockchains will do. Okay, consensus algorithm. So as I said, consensus algorithms are the rules that miners follow to group the transactions and add it to the block, right? So these are the four most used consensus algorithm. One is proof of work. This was followed in Bitcoin and later it was followed in Ethereum, right? The early stage of Ethereum. So proof of work is what I explained before. We have to calculate a number. We have to do some work and prove that you have verified the transaction and added into the block, and you get the reward. Reward is nothing but for adding. If a person has successfully added a few transactions into a block, then he will get some reward in form of in Bitcoin. He will get few Bitcoins, and Ethereum he will get few Ethereum. Okay, few users. So that is proof of work. I already explained it. You have to calculate a number to make the result lesser than a given network difficulty, and then you prove that you have done some work. You open the transaction. That is proof of work. The main disadvantage of proof of work is resource incentive. So to calculate that nonce number is not that easy, right? We have to try the carbon footprint will be more because we have to we cannot do it with normal systems, like we need GPUs to do that. Okay, so it's completely burning the system. So so that is where people started migrating from proof of work to proof of stake. Proof of stake is like it is a kind of rich get richer concept where I have 2 coins in my account. I stake the coin. Okay? I stake the 100 coin. So whoever stakes the most number of coin, they get the chance to mine the transactions. And then once they mine, they get the reward and they can take back that staking. Why we are staking means I say I pay $100 ethers, okay, or 100 bitcoins. I stake 100 bitcoins, and then I do the mining. If people prove that I'm not doing my work properly, I have included some wrong transactions in the block. If people can prove that 100 bitcoins or ethers can be penalized, and I lose that 100 bitcoins. Okay, so it's a kind of betting where I keep 100 and then do the work, and if the work is proven wrong, you take the coins. Or if the work is correct, I will get back the coins and then I'll get the reward amount also. Okay, so whoever gets the highest coins, they get the chance to mine. Okay, this is proof of stake. Ethereum has already moved to proof of stake. It's called Ethereum V2. So this algorithm is being used apart from Bitcoin. Others are moved to proof of stake. One advantage is it's not using that much resource. Okay, it's not we are doing so much work, right? So that is one advantage, and one disadvantage is, as I said, it's like a rich get richer. Okay. And delegated proof of stake is a kind of proof of stake where whoever stakes the most coins, they delegate the mining in charge to some other person. So whichever person that person points to, they get the chance to mine the coins. That is delegated proof of stake. Okay, I win the bet, and then I delegate the responsibility allowed to some other person. Okay, and then we have the practical Byzantine fault tolerance. That is one consensus used by Hyperledger. So it's a kind of thing where a person will be chosen as a leader. The transaction, all the transactions will be routed to that person, and that leader will broadcast those transactions to a set of backup nodes, key choosers, and then everyone has to just verify the authenticity, and then finally it's at a high level. This is what practical BBF is. So I recommend you go through what is first of all Byzantine's problem. It will be in the internet. So it's a kind of military kind of situation where in a group of things, what if 51% of the lot of commanders are manipulated by a wrong instructor, or whoever from the opposite party or an instructor whose intention is to destroy this army, right? They will choose, they will manipulate the instruction, and majority of the soldiers will get the wrong instruction and act accordingly, so that the entire operation gets into trouble, right? So that is called Byzantine's problem, and this practical Byzantine fault tolerance is one such algorithm to overcome such problems. So in our case, it's nodes, right? What if more than 50% of the nodes get some wrong instructions? Okay, then most of the transactions will be invalid. So this algorithm solves that, which is used in Hyperledger. So addresses, as I said, it is used to identify a person pseudonymously. What happens is we generate a public and private key, okay, and then the public key is somewhat transformed to and it is given as the address of the person to use as a username. He can give it to anyone. For example, if I want to transfer some amount of coins from one person to another, he just needs to give me his address so that I can transfer. The amount gets transferred, and then the private key associated with the public key, right? That acts as his password. Okay, so he needs his password to use this coin. Okay, to send to another person also he needs his password. Okay, but to receive he typically doesn't need any password, but to use that that is the private key. He has to keep it himself, and then use as his password. Okay, so this is what our address is. Any person or a smart contract is identified using a blockchain address. Okay, wallets. So wallet is typically a program that or a device that stores the public and private key information on behalf of you, so that you can use them when needed. Okay, it's just like a wallet we say, but in Web3, the private key can be stored as cannot be stored as it is, right? So we need wallets to store our key pairs, and these are the typical categorization of wallets. One is software or hardware wallet. So hardware wallet is a device where we store our information, and then software is typically a program like Madan where we keep our private and public key. And then hot and cold wallets in the sense. Hot wallet means it will be always connected to the internet. Okay. And cold wallet means it will be an offline wallet. We don't need any internet to run, but when needed, we connect to the internet, and then it's typically like a browser and an Outlook program to access your mail. So the program will be offline. We need it to connect to the internet. So the advantage is hot wallet. We have a risk, right? Since it's always connected to the internet, third party can come and hack our private keys. Whereas cold wallet is safe, but it's the ease of operation is a little bit difficult. So keystroke is custodial and non-custodial wallets in the sense. Custodial means a third party will act on our behalf, and they will store our private key on our behalf. So that is a few people feel risky, right? Why someone else should store private keys? Non-custodial wallet means everything we will store. Okay, third party will not have the access to the private keys. We will store. So these are the categorization of wallets. So you have to choose your wallets carefully to store your addresses based on your use case. Okay. So one common wallet we use is MetaMask, which is a hard wallet which comes under non-custodial type. It's a software wallet which is a hard, and then it comes under non-custodial type. Okay, one example I'm saying. Okay, smart contracts. This is the most driving factor of any blockchain. What is a smart contract? So many people at the initial stage they will get confused what is a smart contract is. Okay, so this is where blockchains, apart from storage and coin transfer, it started to be used for computing also. Okay, so smart contract is very simple. It's just a computer program. Whatever program you write in Java, right? The same program is called a smart contract in blockchain. Simple, okay. So like we have JVM virtual machines. We have in Ethereum we have EVM, Ethereum virtual machine. So in every blockchain we have a virtual machine to execute that program actually. So the here the difference is the program is in a typical application we will have a program stored in an application layer, and then we will have the data that is being operated that will be stored in the storage layer, right? Here in blockchain, so imagine the application also is residing in the data storage layer. So blockchain is both data and then the computation for it. So the smart contracts will also be a data inside the blockchain, but the thing is it can get executed and change, and then it can change data inside the blockchain. Clear? Okay. So it's, as I said, it's just a computer program that executes inside a blockchain and changes the state of the blockchain according to create new transaction, modify transactions. Okay. Okay, it is this is where it is used for automatic transfer of tokens. So everything is based on smart contracts, right? If I transfer some tokens or if I execute transactions, for example, a person's identity, a new entity is created. So everything is just a method inside that smart contracts. Okay. So the contract itself, it resides in the blockchain. It will have a specific address, similar to an individual address. We will have a contract address. So that if you want to execute that contract, right? If you want to execute the smart contract, call a method, then we will point to the address of the smart contract and then say call this method for the smart contract which resides at this address. Okay, this is how contracts are executed.